Hello, my name is Lynn Greathouse. I am currently teaching high school science at a small school in the Great Lakes Bay region while working to complete my master's in instructional technology and e-learning at Saginaw Valley State University. The following presentation is a summary of my thesis work about the effects of the flipped classroom on lesson pace. A fantastic group of 36, 15, and 16-year-olds in my third and fourth hour chemistry classes were the participants in my study. I had learned about the flipped classroom at a professional development in-service about a year ago from one of the leaders in the field, Jonathan Bergman. When we began this school year, administrators requested that teachers include more reading and essay writing in class and develop more student-centered lessons. As I was not covering all of the Michigan high school content expectations for chemistry in a school year, I wondered how I would accomplish this. Then it dawned on me. If I flipped the classroom, I might have more time to complete what was expected of me. Mr. Bergman mentioned that if the flipped classroom is instituted, there would be more time in the classroom. This became the focus of my study. What is the effect of the flipped classroom on lesson pace in high school chemistry? Sub-questions followed with how does this new environment affect my interaction with students, student confidence, and their academic achievement? In the flipped classroom, the traditional activities of the learning environment are switched. Lecture is completed at home, and homework assignments or other activities are accomplished in the classroom with teacher support. This allows for the student-centered learning. I flipped my classroom by creating videos from PowerPoint slides. I annotated as I recorded with the Doceri app, then posted the videos on YouTube. My chemistry students viewed the videos at home and took notes, which were graded. When we were together in class, we would start the class with a whole group discussion about the video, work a few more examples, and then the students would work on traditional homework problems in differentiated groups. I would circulate from group to group to assist with the assignment. To study pace, I dusted off my chemistry lesson plans from 2 years ago and compared them to the lesson plans for this year. I counted the days it took to complete each of 2 chapters in the pre-flip and post-flip scenarios. To study student-teacher interactions quantitatively, I tallied the number of times I spoke with each student in 8 pre-flip lessons and in 8 post-flip lessons. To measure these interactions qualitatively, I took note of the subject of the conversations of the students before and after the flip. Students also participated in a survey to gather information on interaction with the teacher. Pre and post flip survey and journal entries were used to measure student confidence. Achievement was measured with overall class grades and chapter test grades before and after the change in the learning environment. In the flipped classroom, the pace was 30% faster on the average. Chapter 9 was completed in 3 less days, even with a biology review added 5 minutes a day for 9 days in order to prepare the students for standardized science testing. Quantitative results of teacher communications showed that in the flipped environment, the teacher increased communication with students by almost an average of 1 per day. On day 8, test day, the interactions decreased from pre-flip to post-flip. The topics of the students' conversations did not change until the 5th week of the study. At this point, the students started sharing more details about home life and extracurricular activities with me. When students were surveyed about confidence, the responses on the survey showed that they were more frustrated with chemistry before the flip than after. After the flipped classroom, students were more confident before a test. In their journal entries, many students attributed the growth in confidence to the support received from the teacher and peers when completing homework in the classroom. Although achievement did not show growth from pre-flip to post-flip, with class average grades in the third hour chemistry class, a .6 growth was shown in the fourth hour group. The mean of class average scores on all tests improved 2% from pre-flip to post-flip. 10 students improved their overall grades, 14 had no change, and the grades of 12 students declined. The increased pace of the flipped classroom gives the teacher flexibility of time to add more student-centered activities like inquiry-based labs or focus on what needs to be added to lesson plans to improve the school as directed by administrators. In a study by Jewett, it was found that some topics were better studied at a slower pace than others, which could explain the differences between Chapter 9 and 10 test scores. As Bergman and Sams discussed, the flipped classroom created a caring environment, reduced frustration, and increased confidence. Although the main focus of many of my students' futures will not be chemistry, the confidence they gained in the chemistry classroom, due to support from their teachers and peers as a result of the flipped classroom, could be a large contribution to their success in any chosen field. I look forward to your questions. Thanks for listening.